Today we're going to talk about scientific notation. Now, scientific notation is a way to take a number that is really, really big or a number that's really, really small and write it so that it's easier to understand and easier to see. So, scientific notation is going to look something like this. You're going to have some number that's going to be multiplied by 10 raised to some exponent. And there are some rules about scientific notation. So the first rule that you need to know is that this number here has to be smaller than 10 and it has to be bigger than 1. So here's what I mean. We can have numbers like 3.2, or we could have a number like 1.1, or we could have a number like 7.253, or we could have a number like 9.892, because those are all in between 1 and 10. However, we cannot have a number like 11.3 because that's larger than 10. We cannot have a number like 15.25 or 23 apparently. We cannot have a number like 0.27. Those numbers are all outside of our parameters. So this number here has to be in between 0 and 10. Now if you look at number 1, I have 5,100,000 and I need to write that in scientific notation. Now the first challenge that I'm faced with is how do I turn this number into a number between 1 and 10? Well, currently the decimal place in this number is at the very end and I need to move that decimal place so that this number is now between 1 and 10. So to do that, I'm actually going to look at the first number that I see. Now the first number that I see is 5. Now my decimal point is going to move right after that 5. Then I need to write down all of the numbers that come after that before the zeros start repeating. So what I mean by that is here's the number 1, and it's followed by 0, 0, 0, 0, 0, where they start repeating. So that's the number that needs to go after the decimal point. Then I'm going to write my times 10, and now I just need to figure out what this exponent's going to be. Now to figure out what the exponent's going to be, you really just need to figure out how many places your decimal moved. Now if your decimal moved to the left, which means that my number is a big number, my exponent's going to be a positive. So if I count here, we go 1, 2, 3, 4, 5, 6 places. So that's 5.1 times 10 to the 6th. Now on number 2, again, we need to start by turning this large number into a number between 1 and 10, which means I want my decimal point to be right after my first number, so 8 point. Now I need to write down all of the numbers that come after the 8 before you start seeing repeating zeros. So if you'll notice, I do have a 0 right after that 8, but it's also followed by a 3. The repeating zeros don't start until after that 3. So the 0, 3 needs to come after that decimal. Now I'm going to bring down my times 10, and I want to figure out what my exponent's going to be. Now instead of sitting here and counting every single little place that it moves, remember a comma happens every 3 places. So I can really start and say 3, 6, 9, and 1 more makes 10. So this is going to be 8.03 times 10 to the 10th power. On number 3, I want the decimal to go right after that first number. So 1 point, and then the numbers that come after it before the zeros are 4, 2, 5. So 1.425 times 10. Now I need to figure out what that exponent's going to be. So it starts here and we go 3, 6, and 1 more makes 7. So 1.425 times 10 to the 7th. Now go ahead and pause the video and do number 4, 5, and 6 on your own. So on number 4, I hope that you got 6.807 times 10 to the 13th. On number 5, 1.4 times 10 to the 4th. And on number 6, 9.0105 times 10 to the 11th. On number 7, notice this is not a really large number. Instead, it's a very small number. It's much less than 1. So we're still going to go through the same process to get this number that goes before the times 10. I want you to put the decimal behind the first number that you see that's not a 0. So that's a 3. So it's going to be 3 point, and then whatever comes after it, that 4, 5. Then we're going to have times 10, but since this number is a very small number, that means my exponent is now going to be negative. Now, since it's a small number as well, we don't have any commas. So that means I am going to have to count 1, 2, 3, 4. So 3.45 times 10 to the negative 4th. Let's try it again on number 8. The first number that I see that's not a 0 is a 5, so we're going to have 5 point, then the numbers after it, 3, 2, times 10 to the negative, and now I just have to count 1, 2, 3, 4, 5, 6, 7, 8, 9 to the negative 9th. Let's try it again on number 9. I want the decimal after that first number, so 9.13 times 10, and I'm going 1, 2, 3, 4, 5, 6, so to the negative 6th. Again, go ahead and pause the video and try 10, 11, and 12 on your own. So on number 10, hopefully you got 8.34 times 10 to the negative 7th. On number 11, we have 5.5 times 10 to the negative 3rd. And on number 12, I have 7.4 times 10 to the negative 1st. On the next section, it says express each number in standard form. Now, standard form is what we started with on the last section. Now they're giving it to us in scientific notation, and we have to write it out as a regular number. So the key to this guy is to look at the exponent that you're working with. If it's a positive exponent, you're going to move your decimal to the right. If it's a negative exponent, you're going to move your decimal to the left. Now the number represents how many spaces you're going to move it. So for example, on number 13, I have 4.91. The decimal point is going to move to the right because it's positive 4 units. So 1, 2, 3, 4. Now in these blank spots, we're just going to fill them with zeros. So I have 4, 9, 1, 0, 0. Now the last thing you need to do is just go back through and put in your in your commas. So 1, 2, 3, comma. We have 49,100. On number 32, we have a negative exponent. So that means I'm going to have to move my decimal to the left 5 units. Well, if I have 3.2 and I'm moving it to the left, I'm going to go 1, 2, 3, 4, 5. That means I'm going to be left with 1, 2, 3, 4 zeros. So 0.0000032. On number 15, I have 6.03 times 10 to the 8th. That means I'm going to move my decimal to the right 8 places. So if I want to do this without drawing the loops and trying to figure it out, let's start with the 6. And if I move it over 1, I have the 0. And I move it over another 1, I have the 3. So that's 1, 2, which means I have 6 more spaces to move since I had to move 8 places. That means after moving it the 2 for the numbers, I can add 6 zeros. Now we go back through and add our commas. So start from the end, 1, 2, 3, comma, 1, 2, 3, comma, 603 million. Go ahead and pause the video and do the next 3 on your own. Alright, on number 16, hopefully you got 0.000002001. On 17, hopefully you got 10 billion to million 400,000. And on 18, you needed to get 500,000. Now in the next section, we're going to talk about what happens when we multiply scientific notation together and how to get the results. So it says evaluate each product, express the results in both scientific notation and standard form. Now here's something you are not allowed to do. You are not allowed to just put this in your calculator and get a result. Sometimes it might work, sometimes it won't. So we're just going to say that it won't work and we cannot do it. Now, we're going to treat this as if we were exponents. If you'll remember, if I was taking 2x to the 3rd and multiplying that by 8x to the fourth, they had the same variable raised to exponents and coefficients. So we treated the coefficients just like normal. I took that 2 times 8 and I got a 16. And then when I multiplied the x to the third times the x to the fourth, I added their exponents and got x to the seventh. Well, if we look at number 19, I have 3.4 times 10 to the third and 5 times 10 to the fourth. These are kind of like these guys were set up right here. So the coefficients in this guy, which were 2 and 8, are going to be similar to the coefficients in this guy, so the 3.4 and the 5. Now the variable, which is the number or the term being raised to the exponent, is going to be like 10 over here, and then the exponents are going to be the same. So these are really going to be similar to what we did in the past. Now to solve this, all we need to do is start with these coefficients. I'm going to start by just taking 3.4 times 5. So in my calculator, 3.4 times 5 is going to give me, well, come on, 17. Okay. Then I'm going to bring down my times 10. And since I'm multiplying these two guys, I'm going to add those exponents. And 3 plus 4 gives me a result of 7. Now, I hope that you notice that this isn't actually in scientific notation. It looks like it will be, but this number is supposed to be between 1 and 10. So, to make it between 1 and 10, I'm going to have to move this decimal place, since it's currently after the 17, in between the 1 and the 7 to make it a 1.7. But I have to keep this equation balanced. It's kind of like one big teeter-totter, where I started off with 17 times 10 to the 7th, and since I changed this side, I need to change this side in an equal manner. Notice 17, when it got changed to 1.7, got smaller. So this number went down by 1 place because I moved the decimal 1 place. Now to keep that balanced, I need to make this exponent bigger by the same amount. So since I went down by 1 place, I need to go up by 1 over here, and that's going to change it to 10 to the 8th. Okay? Now, this final answer is definitely in scientific notation. Now all I have to do is write it in standard form. So that means I need to move the decimal 8 places to the right. So if I move it once, I have 17. Then I have 7 more places, so I'm going to add 7 more zeros. Finally, I'm going to go back in and put my commas. 1, 2, 3, comma, 1, 2, 3, comma, and I have 170 million. And I'm going to box my 2 answers. Let's try it again on number 20. Again, we're going to start by multiplying my coefficients. So I'm going to take this 2.8 times 1.9. So 2.8 times 1.9, and that's going to give me a result of 5.32. So 5.32. Then I'm going to bring down my times 10, and I want to add my exponents. So negative 4 plus 7 gives me a positive 3. Now, if you'll take note, 5.32 is between 1 and 10, so this is in scientific notation. I don't have to change it. Now all I have to do is write it in standard form. So I can move my decimal 3 places to the right, 1, 2, 3, and get 5,320. Let's try it again on number 21. Again, start with the coefficients. Take your 6.7 times 3, so 6.7 times 3, and I'm going to get 20.1. Now I need to bring down my times 10 and add the exponents. So negative 7 plus 3 gives me a negative 4. But this guy is not between 1 and 10. This is larger than 10, so I need to move that decimal place 1 to the left, and I'm going to get 2.01. But since my actual number got smaller, when I changed from 20.1 to 2.01, excuse me, I got smaller by one place. So now my exponent needs to get bigger by one place. So if I take -4 and add 1, I'm left with an exponent of -3. Now all I have to do is put it in standard form, and I'm going to move it 2 to the or 3 to the left, excuse me, and I'm going to get 0.00201. All right, go ahead and pause the video and try number 22 on your own. Okay, so when you multiplied your two coefficients together, you should have gotten 18.63, then added your exponents and you would have got 10 squared. But I needed to make this between 10 and 1, and so I moved the decimal place 1 to the left, and I got 1.863, increased my exponent by 1, and I get 10 to the third. And my result in standard form is 1,863. Now on number 23, we're taking 1.2 times 10 to the -4th and squaring it. Now we understand that if I'm squaring it, I'm really taking 1.2 times 10 to the -4th and multiplying it by itself. But instead of rewriting it and multiplying it out, let's use our knowledge of exponents to help us solve this. Now remember, if I were to have like 3x to the 4th squared, we kind of distributed that exponent and took 3 squared to get 9, and took x to the 4th squared, multiplied those together, and got x to the 8th. So using that information, let's see if we can solve 23. Let's start by taking this 1.2 and squaring it, which gives us a result of 1.44 times 10, and now we multiply these two exponents together. So -4 times 2 gives me -8. Finally, we need to change this to standard form. So I'm going to move my decimal place to the left 8 units. So we should be left with 0.000000144. So there should be 7 zeros there. On number 24, again, we're going to start by taking this coefficient and squaring it. So 5.9 squared gives me a result of 34.81. Then I'm going to multiply these two exponents and get 10 to the 10th. But this guy is not between 1 and 10, so I need to move my decimal place 1 to the left to get 3.481. And since this number got smaller, my exponent needs to get bigger, and I have times 10 to the 11th. Now, if I'm moving my decimal place 11 places to the right, 3 starts out in front, and then 1, 2, 3, so 4, 8, 1. 11 minus 3 is 8, so 8 zeros. Then go back through and put in your commas. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So 3.481 times 10 to the 11th is really 348,100,000,000. Let's try it again on number 25. I want to start by taking 3.6 and squaring it. Oh goodness. So 3.6 squared gives me 12.96 times 10 to the 5 times 2 is 10th. Now I need to change that 12.96 to a 1.296, and my exponent will go up by 1 and I get 10 to the 11th. So again, that's 1.296, so that's 1, 2, 3, 6, 4, 5, 6, 7, 8, 9, 10, 11. Go back through, put in your commas, and we have 129,600,000,000. Go ahead and pause the video and do 26 on your own. Now for this guy, hopefully you end up with 16.81 times 10 to the 14th, which is really 1.681 times 10 to the 15th, which gives us oh goodness, this is 100,000, million, billion, trillion. I don't know what comes after that, but it's a very large number, and that's okay. Sometimes we're going to get large numbers on this problem. Alright, the next thing we're going to talk about is quotients. Now quotients are just division, so we're just going to go through the process just like normal. We're still going to handle division like normal. So let's take these coefficients and divide them. 4.9 divided by 2.5 is going to give me 1.96. Then I'm going to bring down my times 10, and remember when it's division we subtract the exponent. So I'm going to take my numerator's exponent, which is negative 3, and subtract my denominator's exponent, which is negative 4. So negative 3 minus negative 4 gives me a result of positive 1. Well, positive 1 really just means that I'm moving my decimal place 1 to the right, and I'm left with 19.6 in my standard form. Let's try it again on number 28. I'm going to start by taking my numerator and dividing it by my denominator. So 5.8 divided by 5 gives me a result of 1.16. Then I'm going to multiply that by 10 to the power of 4 minus negative 2, which turns into a positive 6. Now to write that in standard form, I'm going to move my decimal place 6 units to the right, which gives me 116,000, which is 1,160,000. On number 29, we're going to try it again. So we're going to take that 1.6 and divide it by 4. And I'm going to, oh goodness, 1.6 divided by 4 gives me a result of 0.4. Then that's going to be times 10 to the, so 5 minus negative 4 gives me 9. Now if you'll notice, even though this number isn't bigger than 10, it's less than 1, which means this cannot be scientific notation. So I need to make this guy bigger than 1 by moving my decimal place 1 to the right. Well, that's going to turn this into a positive 4. So since my number got bigger, now my exponent needs to get smaller by 1, so that's going to be times 10 to the 8th. So that's going to be a 4 followed by 8 zeros. On 30, I have 8.6 times 10 to the 6th over 1.6 times 10 to the negative 3rd. So I want to divide these two guys right here. So I'm going to take that 8.6 divided by 1.6, and I'm going to get 5.375. Then that's going to be times 10, and 6 minus negative 3 will give me a positive 9. Well, this is nice already and in scientific notation, so to put it in standard form, let's move our decimal place 9 to the right. So 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Go back through, put in your commas, and we have 5,375,000,000. Okay, 31, we're going to take that 4.2 and divide it by 6. And I'm going to get 0.7 times 10. And now I'm going to take that negative 2 and subtract negative 7. And that's going to give me a positive 5. But pay attention, this is this is less than 1, so it needs to be greater than 1. So I'm going to move it 1 to the right, which will be 7 times 10. So since this got bigger by 1, this needs to get smaller by 1, which will give me to the 4th power. So that's 7 followed by 4 zeros, 70,000. Alright, go ahead and pause the video and do number 32 on your own. Alright, hopefully you got 3 times 10 to the 1st power, which is just 30.